and welcome back to differential equations. Class number 3, section 1.4, separable equations. Again, for the third time. You did that in calculus 2, and then this is the second time in calculus. So 1 plus 2 is 3. We start math with that. Separable equations, we have already discussed that the gist of that is to put all of the variables of one kind on one side and all of the variables of the other kind to the other side. So if you have x and a y, x is going on one side, y is to the other, or maybe y and t, whatever you have. So the idea is that this dy dx is going to be some combination of x and y, and we are trying to separate the variables so that we can integrate both sides. So we are going to put all of the y's on one side and put all of the x's on the other side, and then we are going to hit both sides by integral, eventually obtaining that f of y, which is y of x, is equal to some antiderivative plus constant c. Now this thing over here is that general solution, and we do not have to put plus c on both sides because it will be plus c1 on one, plus c2 on the other, and then when you put them together, let's say c2 minus c1 can be called capital C. So it's fine to put plus c on one of the sides. I usually put on the right. And now what you do is, if you have initial conditions, you will be calculating the value of that c and pushing further. So the problem will depend, the type of integration you're going to use will depend on the type of the problem. We know that we can do integration by parts, right? We can do trigonometric substitution from Calc 2. We can do the integration by parts. Did I say that one already? U sub. So there is a partial fraction decomposition. So there is a whole bunch of things that you can see. So let's just do a few of these non-application problems where you just grind through calculations. We can, I don't know, let's pick two of them, one without and then one with initial condition. So I'm on page 43 in a current textbook, but then whatever you have, it's fine. What looks awful and bad? They all look awful and bad? Give me a number between 1 and 18.
42.
You're disqualified for the rest of the semester because 42 is not between 1 and 18.
9.
Anyone? 9? I heard 9, so 9 it is. I could have rounded that one, but I have these selective hearing issues, you know what I mean? So we have this, and good luck, right? So now we separate variables. We are going to bring all of the y's on the left and all of the x's to the right. So I will have 1 over 2y dy is equal to 1 over 1 minus x squared dx. And it's all about working this out in terms of integrals now, because we are ready to integrate both sides. And when you put these integrals now, we have 1/2 integral dy over y, that's the easy one, and on the other side we have integral of what? That was with plus. This one has a minus. Let me just check in the book one more time. Yep, it's a minus. So it's not, unfortunately, inverse tangent because it's a minus x squared. It was close. It was close. Hmm? Is it? So let's pick your poison. What do you want to do? Partial fraction decomposition or trig sub? Which one? Partial fraction decomposition, obviously you want to practice that thing because of your what's coming up? Laplace transforms are coming up, and that's going to be a lot of partial fraction decomposition for inverse Laplace. So we want to practice partial fraction decomposition. So first I'm going to use the fact that a minus b is the same as negative b minus a to put x squared first. So I'll have negative 1 divided by x squared minus 1, which is x minus 1, x plus 1 when you factor. And then there is dx on top. I am going to solve this integral on the side because I have to do all the partial fraction decomposition fun stuff, and then we will go from there. So we know that we have, in this case, 1 over x minus 1 plus 1 over x plus 1 is equal to negative 1 over both parentheses multiplied, and then, sorry, these are a and b on top. Oops. And now we cross multiply, so we have ax plus a plus bx minus b is equal to negative 1. So a plus b times x, right? So a plus b is 0, and a minus b is negative 1. If we are to add these two together, we see that 2a is equal to negative 1, from where a is equal to negative 1/2. So if a is equal to negative 1/2, then b better be positive 1/2, so they can add to 0. And now we can go on and perform the integration. So on the left hand side it is ln absolute y. We're not going to put plus c, we save that for the right side. On the right hand side we have integral of negative 1/2 over x minus 1 plus 1/2 over x plus 1, all of that dx. So I have 1/2 ln absolute y is equal to negative 1/2 ln x minus 1 plus positive 1/2 ln x plus 1, and then plus c. I'm supposed to fish out somehow y equals everything else. It's not always going to be possible, but in this case, what should I do? Just put plus c. The 2 gets absorbed by the constant, so it doesn't matter. You don't have to bother with changing that c ever when you are multiplying or dividing by these numbers. All right, now what? Yeah? Nope. We have plus over here. Can't do e because of this. Yes? Awesome. So we combine ln's. We use those sum and product rules and stuff for ln's. So we have ln y is equal to ln, and you have x plus 1 over x minus 1 plus c. Now we subtract this to the absolute value. Subtract it to the left hand side. So we have ln y. Actually, no, sorry, not subtract. Now e. We are ready to e it. So e both sides, and we finally have that y is equal to x plus 1 over x minus 1 times e to the c. So e to the c we can call, I don't know, k. So there you go, k. So this would be the general solution. Y as a function of x is equal to k times x plus 1 over x minus 1. So try it, see if it's good. Yes?
How did you change the left variable versus
Well, it's e to the c. So it's e to the c, so we just call it k. You can call it anywhere. You can still leave it as c. You can put capital A. Every book does different thing. I don't even know what this book does. Anything is fine. Whatever makes you happy. It's math class, so you're supposed to be happy all the time. Yeah. So, is this good? Or we don't care, we just move on? Is this good? Or we just move on? Whatever, right? Just move on. How would you check? Plug it back in a differential equation. Let's do some algebra, see if this is good. If not, we'd have to redo it. Take the derivative, plug it in a differential equation, and make sure that left side and right side have the same, are the same, and you're done.
Why is it multiplied by k when it's supposed to be added?
Add an exponent, it's multiplication.
Oh, yeah.
So what's the derivative here? For check, let's do that blue. dy dx is equal to k times, and we do the quotient rule here, which is x minus 1 squared. We have x minus 1 times 1 minus x plus 1 times 1. So the whole thing is k x minus 1 squared, and on top we have x minus x is gone. We have negative 1, so negative 2, if I calculated this right. Hope I did. So now if I'm plugging everything in a differential equation, which was 1 minus x squared, dy dx equals 2y, I will copy 1 minus x squared. Instead of dy, I have to put negative 2k divided by x minus 1 squared, and that should be equal to, I put the question mark over equal sign, 2 times k x plus 1 over x minus 1. So I already see that these two k's drop from both sides, right, if I divide those. And all I need to do is to make sure that the left-hand side and the right-hand side are the same. So the left-hand side I write as 1 minus x, 1 plus x when I factor, and I still have that negative 1 in front. And on the bottom, I have x minus 1 minus 1 creature. All of the equations you solved so far had a number as the answer. Or for quadratic, you get two different numbers, complex maybe. Now you are getting a function as the answer. So your answer is a function, and those answers could be general, which is plus c, or particular, where you have initial condition. That's going to be next problem. when you compute the value of C. So we found a general solution here. That's as far as we can go. The constant K is floating around, C or capital A, whatever you want to call it. And then, as you know, if you care on the exam, obviously you will do the check. And if it checks out, you know that the problem is. So it's very easy to score high in this class because you can check problems. We are solving differential equations entire semester. So on every test, there are differential equations. Once you get these functions as answers, differentiate them and plug them back in, and if it works out, that's it. And the fact that I don't like you will not carry right on your grade. It's just right because the problem is solved correctly, and that's it. Technically, you beat the system, right? All right. Give me the problem 19 through 28. 24 it is. You know how to pick. See, that's what we like. Tangent x dy dx is equal to y, and we have initial condition that y of 1/2 pi, why 1/2 pi? Just put pi over 2. What the hell? Pi over 2 is equal to pi over 2. I think they wanted to feel special and type 1/2 times pi, and then again 1/2 times pi. So now we have the condition, and we can compute the value of C. All right, so I won't bother you for some time. Just do it. I'll give you 20 seconds, no pressure. Right? Separation again. We have 1 over y dy is equal to cotangent x dx. We integrate both sides. On the right hand side we have good old ln absolute y, and on the right hand side we have the integral of cosine x divided by sine x dx, which is the way we integrate. This time around, which method we use? U sub. Very good. Very basic U sub. U equals sine x. Very good. So du is equal to cosine x dx. So ln absolute y is equal to, and the integral becomes du over u. So ln absolute y is equal to ln, and instead of u, we'll just write sine x. Sine x. There is a cosine x there to cancel it. So sine x is equal to sine x, and we do have the equality that we need for left and right for the problem to be correct. So once we plugged everything back in, it worked out. So we are all good to go. We already did numerous applications for this. We talked about the population. We talked about Newton's law of cooling. We talked about acceleration and velocities. I already did all of these derivations 2 classes ago. So I'm not going to go through every single one of them again. Just go back, watch the lecture if you need to review that stuff before the homework. And then obviously, if you guys have any questions, concerns, we can address those problems at the beginning of the next class. Sounds good? Well, it's not that you have a choice. I just made an executive decision. So yeah, it's not democracy over here. Guys, dictatorships are better, right? It's just everyone is equally disappointed at all times. Look at the chaos after elections, right? 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 Do you agree? Right? There we go. There's a public service announcement at the end of the stream. All right, so we'll restart this for 1.5 and see what we can do. Bye, stream. Think about it, yeah. Political sciences and differential equations. Yeah.